question is like this: ki two identical specimens were tested in a triaxial apparatus. Now you know triaxial apparatus very well. There is derivative stress and confining pressure for first specimen and derivative stress and confining pressure for second specimen. So now in this case there are two specimens. So for two specimens, either we can draw the Mohr circle or we can solve by analytically using the relation between sigma 1 and sigma 3. Now if that same soil is tested in a direct shear apparatus with a normal stress of 600 kN per meter square, then estimate the shear stress at failure. So now in this case we have to determine the shear stress at failure, and question is about the direct shear test. So first of all, direct shear test, what is this? So now in this case, direct shear test, what we will do, beta, ki there will be a shear box. The shear box is something like of this size, 60 to 90 mm. And the shear box have two parts. Now you can clearly see that this is like upper part and this is what lower part. Now in this shear box, first of all we will place this plate and porous stone, and after that we will place the soil specimen over inside this shear box. And this shear box have two parts, you can see. Now point is to be noted, in this case there is direct shear test apparatus. And when we talk about the apparatus, so this apparatus is like this. This shear box is placed over here, you can see, clear. And if you are unable to see, you can see. So now in this case, this is like what? Shear box. So that shear box filled with the soil specimen is placed over here. Now first of all, on this shear box we will apply this load, normal force. Okay? So we will apply the normal force over here. This normal force is what? Capital P, we can say. This capital P, how we will apply? So this is what? Load hanger. From this load hanger we will place, on this load hanger we will place some load like 10 kg, 15 kg, 20 kg. And by this load, this is something like normal pressure. Now point is to be noted that due to this there will be development of excess pore water pressure now there may be drain condition or undrained condition. But point is to be noted, in direct shear test there is no control over drainage as well as there is no instrument of measuring the pore pressure. So now in this case, because that drainage is not controlled and there is no mechanism to measure the pore pressure, that's why this test is preferred under the drain condition. Okay, so this is preferred under the drain condition, so excess pore water pressure should be dissipated out. So wait for that. Once that expulsion of pore water will stop, then we will start the shearing. So once that expulsion of pore water will stop, then we will do what? Now you can see this is a motor, okay, and there is a screw. There is a motor and there is a screw. So now just you have to on this motor. When you will on this motor, so this motor will apply the force, pressure over this arrangement. So now point is to be noted, this is something like a stand. This is something like a stand, and this stand you can see over here. And this stand is placed over the roller. Is placed over the roller. Ye rollers hai. On the rollers this arrangement is placed. Okay. Now point is to be noted that in this case you can see that shear box have two parts. So this lower part of this shear box is fixed with this arrangement, this lower arrangement. And upper part is connected with a proving ring dial gauge. You can see this is the upper part, or upper part is connected with the proving ring dial gauge. This is the proving ring dial gauge and this is attached like this. This is a rod of proving ring dial gauge. This is the top portion of shear box. So this top portion of shear box is connected with this, bottom portion is connected with this roller. Okay. Now point is to be noted, so now just when this motor will start, entire arrangement will move like this in this direction. So we are creating something like what? Shear. When this entire portion will create, so this shear box will also move in this direction, and now you can see there is a like proving ring dial gauge attached. Okay. So now that rod of this proving ring dial gauge is there, so when this entire arrangement will go in this direction, so this rod will also go inside. When this rod will go inside, so there is a spring in this proving dial gauge which will give reaction. Due to this reaction, there will be development of shear in this direction. So now point is to be noted, by this way this lower portion is going in this direction and that upper portion is going like in this direction. So there is a pressure which is acting in this direction, and this is something like what? Shear force. Now point is to be noted that when this motor will be like in continuously operating, so by a constant strain this arrangement will move in this direction, and there will be like increase in shear force, but there is no failure. Why? Because that developed shear stress is not equal to shear strength. So when this motor will be like continuously running, then there will be one situation when developed shear stress will be equivalent to shear strength. And once that developed shear stress is equivalent to shear strength, now there will be what? Failure. At the time of failure, you will see some kickback over here on this dial gauge reading. So from here, we will note the proving in dial gauge reading, that is what? N. Now, point is to be noted, once that kickback is there, so the soil specimen will fail. And now tell me from where this soil specimen will fail. This is the soil mass, and this horizontal force we are applying, this proving in dial gauge is suppose reading is N at the time of failure, and that constant is K. So now just tell me from where that soil specimen will fail. Tell me. So point is to be noted, in this case you can see when this soil specimen will fail. So this shear box have two parts, and this shearing is occurring like this. So always that soil specimen fail from this horizontal plane. It means that failure plane is already predetermined in this case, and this is the limitation of this direct shear test. In this case, that failure plane is predetermined. Okay, so this is a limitation, and now you can see in this case, if we consider the specimen, so here we can say this is something like direct shear test specimen. Clear? And there were like triaxial shear test. Now point is to be noted, there is a big difference between direct shear and triaxial shear test. So this is what? Triaxial. In the triaxial test, in previous lecture we discussed, first of all we have to apply what? Confining pressure, that is what? Sigma 3. And once that first stage is being completed, then we will apply deviator stress. This deviator stress is like additional stress to sigma d we are applying plus sigma d. Point is to be noted, this sigma d we will apply up to the failure. So sigma d at the time of failure we will not. And there will be one particular moment when the soil specimen gets failed. Okay. So now suppose for example that soil specimen gets failed over this particular plane. Now point is to be noted, this is what? Failure plane or critical plane. Now on this failure plane, in previous class we discussed that there will be two stresses, and these two stresses are what? One is tau ff, and this tau ff is the shear stress at the time of failure on the failure plane. Am I right? Now point is to be noted that second force will be equals to what? Second pressure will be equals to what? Normal stress. And this normal stress is applied like acting over this particular failure plane, and this shear pressure is like shear strength in this case. So this tau ff is equals to S, or this S is equals to what? C plus sigma n bar tan phi, if you remember, and this sigma n bar will be this. Okay. Now in this case, this is what? Triaxial shear test. Now we are talking about the direct shear test. When we are considering the direct shear test, so point is to be noted, in this test, this failure plane is predetermined, whereas in this triaxial test, in the triaxial shear test, this failure plane will always be weakest plane, and this plane is not predetermined. That angle will be theta c 45 plus 5 by 2. But in this case, that soil specimen will fail over this failure plane, which is like horizontal predetermined failure plane. Okay, this is horizontal predetermined, because always that failure will take place over here, predetermined failure plane. Now point is to be noted, you can see ki on this plane we are applying some pressure. Okay, so from the top we applied the force capital P. Now point is to be noted, if that area is A, so we can say ki P by A is the pressure, and this P by A pressure will be what? Sigma 1 or sigma n? Tell me. So point is to be noted that this is failure plane, and this P by A is acting normal to this failure plane, and that's why this is what? Normal stress. Okay. Now by the proving we determined what? That N is the dial gauge reading at the time of failure where this kickback will be obtained. K is the constant of this proving dial gauge. So we can say that K into N is the shear force at the time of failure. Am I right? And now if we divide it by the area will be like A, and this A will be the same, this area. Okay. So now we can say that this will be equals to shear stress. And point is to be noted, this shear stress is at the time of failure. It means this shear stress, this Kn by A will be the shear stress at the time of failure, which we can say is like this. Okay. So this is what tau ff. Now there is a difference between direct shear test and triaxial shear test. You have to remember this thing. In the triaxial shear test, we determine this and this, sigma 3 and sigma 1 at the time of failure. Okay. So sigma 3 and sigma 1 we obtained over there. We did not find this sigma and tau f. But in this direct shear test, what we are determining, we are applying some normal stress and corresponding we are determining the shear stress at the time of failure. So there is a difference between direct shear and triaxial shear. Now if we want to determine the major and minor principal stresses in this case, so we can say that if we relate it by the triaxial shear test, so this is something like this, and that major principal stress will act like over here sigma 1, this is what sigma 3, and this is something like what theta c. Theta c is 45 plus 5 by 2. Okay. So there is a difference between direct shear and triaxial shear. So now here corresponding to sigma n we determine the tau ff. Now point is to be noted, if this test you are doing in the drain condition, so this will be like sigma n bar plus u, and whatever that u is developed, that will be dissipated out due to this drainage, and if it is that is dissipating out, so this u will be equals to 0, so this will be equivalent to normal effective stress. Now point is to be noted, so now in this case corresponding to this normal stress we determined what? We determined what? Shear stress. Okay. And now once that normal stress and shear stress is known, then we can say, then we can draw a curve, and this curve is like in between normal stress and shear stress. So on this plane x, this is what normal stress, and because this drain condition is there, so this will be effective stress, and this is what tau. Now in this case, first test we performed at the, suppose for example, sigma n1 bar, and corresponding shear stress at the time of failure is what? Tau f1. Clear? Now point is to be noted, this is the what? First observation. Now what we will do, we will empty this particular specimen, shear box here. Now we will fill the same soil again, second specimen, another specimen of same soil over here, and now we will change this normal force. Now we will change the normal force, and once that drainage will be completed, then we will start the shearing. So now corresponding to this sigma n2, we will obtain this kickback, and corresponding to this kickback, we will determine the shear stress at the time of failure by this relation. So this second reading, so corresponding to this sigma n2 bar, we will determine the tau f2, and similarly third observation, third specimen of same soil, we will change the normal stress, and correspondingly shear stress at the time of failure we will obtain. Okay? So now these results we can draw over here on this curve. So this is first observation. Now second observation is, suppose for example, corresponding to sigma n2. Okay? This is what? Tau f2. And third observation, suppose for example, this is the sigma n3, and correspondingly this is what? Tau f3. Now when we join all these points, so we will join this points like this. Okay. So by this way we will join all these points. Clear? Clear? Now in this case, we obtain this straight line, and now tell me, what is this straight line? What is this straight line? So now in this case, this straight line is what? Mohr failure envelope. And this Mohr failure envelope we are obtaining direct in this case, whereas in the triaxial shear test, we first drawn the Mohr circle, then common tangent was the Mohr failure envelope. Here we are determining directly. So now that's why this is also called like direct shear test, and point is to be noted that y-axis cut is equals to what? Cohesion C dash, or this is what? Effective friction angle phi dash. So by this way, this graphically we can determine the C dash and phi dash. But if you want to determine the C and phi analytically, so now this tau f we are obtaining corresponding to this sigma n. This tau f is what? Shear strength. So hence we can say this S is equivalent to something like tau f, and tau f is equals to what? C plus sigma n bar tan phi. And hence we can say this is what? This relation will be applicable over here. So you can take any 2 points over here. So corresponding to 2 sigma n, there will be like 2 equations of tau f, and then we can solve the C and phi. So this is what? This is the triaxial shear test, direct shear test. But this direct shear test have many limitations in compared to triaxial shear test. And most important limitation is what? Here failure plane is predetermined, here this will be the weakest plane. There is no control over drainage in this case, but there was control. There were like valves. In this case, there is like no mechanism to measure the pore pressure, but there were the mechanism of pore pressure. So there are many limitations in between this this direct shear test. So generally we prefer the triaxial shear test because it will give the results accurately. Okay. So now that concept of this direct shear test we will apply in this particular problem. So this problem is like this, there is like 2 conditions. First, triaxial shear test. So there are some observations of triaxial shear test. So given data. Now we are solving the question. So specimen 1. There are 2 specimen. Specimen 2. Clear? And triaxial shear test is there. Triaxial shear test. So sigma 3, sigma d. So in the first specimen, that sigma 3 is what? 200, and that sigma d is 770. In the next specimen, sigma 3 is 400, and that is 1370. Clear? And now question is asking about the C and phi analytically. So point is to be noted, sigma 3 and sigma d is given. So now we can say sigma 1 will be equals to what? Sigma 3 plus sigma d, and this will be 970. This sigma 1 will be equals to sigma 3 plus sigma d, that will be equals to 1770 kilopascal. Clear? Now by this way that sigma 1 is obtained, and now we will make the equations. And we know at plastic equilibrium at failure condition, interrelation between sigma 1 and sigma 3, and that sigma 1 is equals to sigma 3 10 square 45 plus 5 by 2 plus 2c 10 45 plus 5 by 2. Clear? So this is what? This is the sigma 1 and sigma 3 interrelation is there. Now when we are making the equation, so we can say 970 is equals to sigma 3 200 10 square 45 plus 5 by 2 plus 2c 10 45 plus 5 by 2. Okay. Now point is to be noted, this is the equation number 1. Equation number 2, 1770 is equals to 400 10 square 45 plus 5 by 2 plus 2c 10 45 plus 5 by 2. So now we know there are 2 equations and unknowns are also 2. So 2 unknowns, 2 equation we can easily solve. Okay. So now in this case we can say that this we are doing subtraction, and hence this will be cancelled out. Now it will be like 200 10 square 45 plus 5 by 2, and this will be like 800. Okay. So this is what? This is the equation, and now we can solve the phi. For the phi, solve it. So this phi comes out to be 36.87 degree. Clear? Now put the value of phi in any equation. In any equation you can put, and if we are putting this in suppose for example first equation, so we can obtain the value of C. So 970 minus 200 into 4 divided by 2 divided by 10. 45 plus 5 is 36.87 divided by 2. So this comes out to be 42.499. So we can say 42.45 kilonewton per meter square. Clear? So this is what, this is the cohesion, kilonewton per meter square, and this is what, this is the phi. Clear? So this is the first part of this particular problem, to determine the C and phi. So C is 42.45 kilonewton per meter square and phi is 36.87. Next, if the same soil is tested in direct shear apparatus with a normal stress of 600 kilonewton per meter square, then estimate the shear stress at failure. So now that specimen is same, so C and phi will remain same. And here you can see in the direct shear test, that equation which will be applicable will be what? This shear strength equation, C plus sigma n bar 10 phi. So we will apply this only. And in the part 2, we can say that S is equals to tau F, shear stress at the time of failure, will be equals to C plus sigma n bar 10 phi. Okay. So now in this case, tau F is equals to C, that is equals to 42.45 plus, there is nothing mentioned about the pore water. So this total stress, whatever that normal stress is there, that is 600, that same we will take over here also. That is 610 of phi, and that phi is equals to 36.87. Clear? Now solve it. 600 is the normal stress. So this tau F comes out to be 492.45 kilonewton per meter square. Clear? So by this way we can determine the tau F. So this is what, second part. Clear?